In this problem, we are asked to directly use the definition of a Laplace transform to find the Laplace transform of f of t equals t squared. Now this, of course, comes off the usual table, but we're asked to actually find the Laplace transform for ourselves. So the definition of Laplace transform is f of s equals integral from 0 to infinity of the function that we're transforming, t squared, times e to the minus st dt. And so the question is to find whatever this integral is. To do this, we have to do integration by parts, and actually have to do it twice. So let's let u equal t squared, and we'll let dv be equal to e to the minus s times t. Then du is equal to 2t dt, and v will be equal to negative 1 over s e to the minus st. So applying integration by parts, we get t squared, u times v, over s, negative e to the st from infinity to 0, minus integral from 0 to infinity of v du. So that works out to be negative 2t over s e to the minus st dt. Okay, now let's see what happens over here. Over here we have infinity times 0. So technically that's an indeterminate form that requires L'Hopital's rule, but we'll just use our rule of thumb that exponential decay always beats polynomial growth. So plugging in infinity, I get 0. Plugging in 0, I get t equals 0 here again, so 0 minus 0. Minus, plus, minus and minus becomes plus. The 2 over s I can bring outside the integral, so integral from 0 to infinity, t e to the minus st dt. Okay, now once again we have to apply integration by parts. So let's let u equal t, and let v equal e to the minus st dt. Then dv will be equal to negative 1 over s e to the minus st, and du is equal to dt. So again, applying integration by parts, we get u times, I'm sorry, I miswrote that. So dv is equal to e to the minus st, v equals negative 1 over s e to the minus st. So u times v, we get negative t over s e to the minus st. St goes from infinity to 0. Then minus integral from 0 to infinity of v du. So I still have the 2 over s here. Forgot the 2 over s here. Then we get negative 1 over s e to the minus st dt, multiplying these two. Okay, once again we plug in t equals infinity. If t equals infinity, we have polynomial growth and exponential decay, so that's 0. If we plug in t equals 0, and that's t equals 0, not s equals 0. If t equals 0, we have a 0 on top again, so that's 0. Plus 2 over s squared, integral from 0 to infinity of e to the minus st dt. So that's equal to, now I can just integrate this, I get negative 2 over s cubed e to the minus st from infinity to 0. Okay, now if I plug in infinity, I get 0. If I plug in 0, I get negative 2 over s cubed times 1. And so we end up with that the Laplace transform is 2 over s cubed. Now for completeness, let's say what the values of s are permissible. Now this integral only converges if s is greater than 0. That's our usual rule for Laplace transforms, that this integral is only going to converge if s is greater than 0. And it might be more restricted than that in some cases, but certainly s is greater than 0. The idea being that if s is negative, then I have negative, negative makes positive, and this blows up. But if s is positive, then this decays. So the values of s for which this is valid is s greater than 0, and that is the Laplace transform of t squared.